Okay, so for number 10, we are looking, and for 11, we're looking at all the values. So the only thing that's going to be different is we're going to solve the problems exactly the same, but when we get to the end, we have to represent all answers that could be possible, all going around the unit circle 500 times or going around the unit circle backwards 500 times. So it represents any answer. So on number 10, before we get to that part, notice everything just has a regular x, so we don't have to worry about the rounds. But we have different trig functions. So tangent's going to be the one that you want to change. And you know tangent is sine over cosine. So because cosine is in the numerator and denominator, we can cancel those out. So we're going to have sine x minus sine squared x. You can put them in order if you want, but because we only have two terms, we're just looking at GCF. So the GCF is sine x. If we take out sine, we'll have 1 minus sine x left. So we're ready to split that up. So if we set sine x equal to 0, so if we take a look at our unit circle, we're looking for when the y value is equal to 0. So that happens at 0 and at pi. And we're going to circle the answers because they're not really going to be the final answers here. And then on the right hand side, if we set it equal to 0, we're just looking for when sine x equals 1 or when the y is positive 1, which happens at pi over 2. So if this just said the normal domain, that would be our answer, 0, pi, and pi over 2. But because it says we want all values, we need to represent that if you're at 0 here, well, let's just do pi. If you're at pi, if you go around the unit circle once, you're still going to end up here, and around and around and around. So we're representing all those values. So to do that, you're going to take one of your answers. You're going to do it for all of them. So take 0. You're going to put plus or minus that represents going around clockwise or counterclockwise. All the way around the unit circle is 2 pi, but if you go multiple times, it could be like 4 pi, 6 pi, 8 pi. So you're going to put some variable here, normally it's an n. Okay, and n is just going to represent some integer that it's multiplied by. It could keep going on forever. We're going to do the same thing for all of them. So pi plus or minus 2 pi n, and pi over 2 plus or minus 2 pi n. So when you're writing your final answer, you have all three of these things, but with every one you're writing plus or minus 2 pi n to represent going around the unit circle over and over. So like if we were to go back to number 9, if this asks the same question, you would still have to do your 2 rounds, but when you wrote your final answer, you would be writing, so if you wrote this final answer for number 9, we would write pi over 2 plus or minus 2 pi n. And we would write 3 pi over 2 plus or minus 2 pi n. And you always have to just state that n is 0, 1, 2, or anything bigger than that. So if they ask for all on number 9, that's how your answer would have looked versus just the 2 answers. Okay. Alright, so then for the last one on number 11, it's still in the all part. So if you notice for number 11, we're working with just regular cosine x, so we don't have to do the rounds. We do already have just a similar term here, so we can just combine like terms. If we subtract 3 cosine x over, we'll have negative 2 cosine x equals negative 2. So if we want to divide by that negative 2, we'll have cosine equals 1. So we're looking for when the x value is equal to 1. So that happens at 0. So because this wanted all the possible answers, we're going to make sure we write 0 plus or minus 2 pi n, whereas n represents 0, 1, 2, or that could keep going on forever. So that's how you do it if it says all versus if it just is on a certain domain.